So welcome all. Today we are going to see something about replication. See, till now you have already seen these things like we have replication and fault tolerance and these kind of things. But here we are going to see a little more detail of replication, where one thing that we understand that what a replication can mean, right? We have to keep the copies of our data at multiple points, maybe multiple servers, and whenever needed they can be accessed. In certain cases, if one of the server fails, even then the other is available, right? So what are the things when do we need this kind of replication, right? So first thing can be for performance enhancement. Performance enhancement, how the performance will be enhanced with the use of this replication. Suppose you have your data which has been replicated on multiple servers. In that case, what will happen? Suppose this thing, multiple servers are there, and you have kept your data on multiple servers. So now what happens, those clients which are trying to access the data, if at all the data has been somewhere on a server which is a highly available server, and it may not crash, so very nice server which will not crash, kind of thing, but still it is far from this particular client, right? And if it has been replicated on certain geographically different locations, in that case it will be nearer to the client. It may be nearer to the client which is trying to access the data, right? In this way it can enhance the performance. The other thing I would like to talk here is about load balancing, right? See, you would have heard about load balancing at multiple places. Now let me tell you a way how this load balancing can be done with the help of replication. You may have seen websites, right? So you have your website maybe kept on a particular server. Now this server will have certain IP address, a.b.c.d. Now what happens, there is a DNS server. You will, whenever you will have a website, you will try to have a DNS server. Okay, on this DNS server you will have a name. Your name will be something like your website, yourweb.com. okay. So whenever a client tries to access this location, this name, I should say yourweb.com, this DNS server will map this name to a particular IP address, right? So this IP address, if at all this resource has been stored at this place, the IP address will be a.b.c.d. Now what you are doing is you are using replication, so you are keeping the copies of your resource at this place as well as on these two other servers whose IP address may be something, s.t. something and k.m. something. No problem. Now this DNS server, rather than finding out a dedicated place, dedicated server, dedicated IP address, it will send you on a particular dedicated server, which will in turn find out which IP address, I should say it will send you to this server, suppose this server. So this server will be responsible for finding the IP address of the currently active versions. Maybe if at all the three are working, then which is nearer, no problem. Okay. So in that way, it can also be used for load balancing. How? For with replication, how load balancing is done? You can use, means different options are there, but still one of the option is round robin scheduling. How the round robin will be done? You will start with whenever the request comes in a round robin way. What you will do? You will first send the IP address of this server. Next, for the next request, you will send the IP address of this server, and in the next request, the next server, and it will go on working in a round robin fashion. Okay, so in this way, the total load will be balanced with the help of replication. Okay, so this will also improve the performance. Now another thing we are discussing is increased availability. You can understand that many a times servers may fail. So if you have different copies of data, one of the server even if fails, the other server is still working, right? So sometimes you will see that even if you have suppose k plus 1 servers, so even if k servers are down, the one server can still work, right? So something is better than nothing, kind of thing. So it is also in literature you will see that if you want if in your distributed system, if there is possibility that k servers may crash at one time, in that case you should have at least 2k plus 1 servers. Okay, so but anyway, if you have replication, that will help you in availability. So what I am telling is, servers may fail, networks may fail, and if the network, some router fails, then the total network will be divided, that is partition. So such things may occur, and because of that, replication, in those cases replication may help. If the replicated versions are available, means servers are available in the network, it will help the clients. Fault tolerance. Fault tolerance is that definitely high availability of data is there, but high availability of data may not say that the data is always correct. Okay, so fault tolerance means whatever the data we have, it is always correct, even if the server fails. Even if the server fails, whatever the server fails, if the server fails, even then what you have to do, this server may, whenever it restarts, it may recover all the lost data. It may have only the correct version of data. So all of these things that you have to understand. So for all these things, replication is important. Now for replication, two requirements can also be given. Other requirements are also possible, but still, replication transparency and consistency. What does this replication transparency means? Whenever you have your data, right, physically copied at multiple places, in that case, whenever the client is trying to access your data, client should be unaware that the data has been replicated someplace, and you are accessing a replicated data, and it may be corrupted and kind of thing. Maybe you are getting inconsistent data. These kind of things should not happen. So replication transparency is a requirement whenever you have a replication, that the client should think that it is getting the data only from one place. Consistency means if you have this data copied at multiple places, in that case definitely consistency is something which is required. Consistency means your data is being accessed, this data can be updated. Okay, so whenever this data is updated, so it should be reflected in all the versions of the replication, replicated copies, so that whenever the client tries to access, they should access the correct data. So consistency is mainly related with getting the correct data, keeping the correct data. So these are certain things that we have to keep in mind while thinking about replication in our system. So basically how this system works, replication system, right? Suppose this is the system model, not suppose, this kind of system models are there, where you will have the servers where you are keeping the replication, then you will have replication managers. This is saying that you will have replication managers. This will be you can say processes running on these particular servers for helping in managing the replicas. Okay, you have front end using which you can request to access the data. So the clients can directly encounter with front end. The front end will pass the request to the replication manager. Maybe it will be either to one of them or all of them, depending on the way we have adopted. But still, one thing is that this will send the message to replication manager, and they will talk to each other, and somehow they will fix that yes, data is there, they have to give it. So the data means whatever request was there for that, the request is executed, which means if the read operation is there, the data will be transferred. If it is update operation, data, then all the replicas will be updated, and then response will be given to the front end. So this is something which is done with the this is how replication has to be implemented. So very simple thing, you will have to keep the data at multiple places, and wherever you are replicating the data, you will have to keep track of the replication managers. So whenever you are requesting, there are certain phases. There will be 5 phases of this service request. What are these? So first phase will be request. So what will happen here? The front end will issue a request, either single or multiple replica managers. Okay, depending on whether it is active or passive kind of thing. So you will see, okay, let me clear here only. We have seen the fault tolerant systems, maybe while thinking about transactions, we have seen consistency. There we have seen about fault tolerance, how this transactions are fault tolerant in distributed system, right? So we have seen linearizability, where we are trying to maintain the particular order of execution, right? So we have also seen sequential consistency, where which is also the same thing, a lenient version of linearizability, which means you want to maintain the order. The two things were there, which was your correctness. You will have the correct copy of the data as well as the order. Order should be maintained. So keeping those things in mind, we were having fault tolerance. So I was discussing about single or multiple. Okay, I was actually talking about active or passive. So suppose what is passive replication? Passive replication means your client will definitely interact with front end, and front end will in turn, if at all it is replica managers, replica managers. So front end will interact with only one this replica manager. You will call it as primary replica manager. Okay. So then what happens? So in passive replication, what will happen? Client will definitely this front end will directly talk to only one of the replication manager, and this replication manager in turn will talk to these other replication managers and then execute the these things. Okay. However, in active, what will happen? This front end, in case of active, what will happen? This front end will talk to all of them. This is active. So these kind of replications can be there, but all of them will definitely have these 5 phases. What are these 5 phases? Request. This front end is requesting. So in case of passive, it is requesting to the primary request manager, and in case of active, it is requesting to all of the this replica manager. After that, there is coordination. What happens in coordination? It will find out the particular ordering that one request. This is FIFO. See what happens in FIFO. The one request which comes first should be executed first. Causal ordering or total ordering, all of them also simply talks about the same thing. Causal says that if the issue of request R happened before the issue of request R dash, R is before R dash, in that case the replica manager should handle R dash after R. Total ordering is also same thing, which says that replica manager, if causal ordering is saying how it was requested, total ordering saying how it was executed. So if R was executed before R dash, so okay, it is actually one replica manager is handling R before R dash. In that case, all of the other replica manager also should work R before R dash. That is how this orderings are there, but in most of the cases first in first out ordering is used. The request which comes first is executed first. That is the thing. So other thing, in case of these things, what will happen? Coordination will also check the suppose whenever the request will come, it will come with a unique identifier. So in coordination phase, suppose we are talking about this passive, so what will happen? This will take the unique identifier, check it, and execute it with the help of these replica managers. And this is the next phase, execution, which means we will execute it. Executing means actually, if at all it is read operation, you will perform the read operation and let all of them know that it has been read. If at all it is update operation, then all of the replicas should be updated. Agreement says that okay, it was executed, although it is executed but it is tentative. Tentative means tentative means this execution can be rolled back, this can be undo. So after that is agreement, means that we are getting a consensus about that all the replicas, all the replica managers are ready with this particular thing, and they can now commit. So we have also seen such kind of things in two-phase atomic commit protocols. So similar kind of things as we have seen in transactions. So it will all the replica managers will okay, find the consensus. They will agree that yes, it can be done, and then the response is sent to the front end. Okay. Now the next thing that you have to say is group communication. Here you can understand that you have different servers on which the replication has been kept. So different replicas are there and replica managers are there. These replica managers can be considered as processes. So now these processes will have their own identifiers, process identifier. So all the processes will have process identifier. So now we will, if at all we are trying to send a message to all the replicas, so these replica managers should be aware of each other. Okay, that if it is aware that which are the servers which are having the same replica for this object. In that case, let us have a group formed for all these replica managers. So now what you are trying to have is you will group all these replica managers. So it will help you also in sending the multicast messages to all of this. Now in these groups, as you know, certain processes are running, they may crash. In that case, they may crash and they may not be any longer available. So this group should be dynamic, that one process can leave the group and another this process can join the group. Such facilities should be there in this particular groups. Now let me tell you about group views. Group view is actually the list of current group managers. Suppose you have process P, process P1 and so on. So this is one group view, that in current situation in this particular group you have these two processes. They are having their own unique process identifier. So now when you will have this group management service, it will also take care of seeing that which server has crashed. Since it has crashed, then it should not be any longer the member of this particular group. So it will take care of these things. If at all it has any suspect that this particular server has crashed, or maybe because of network issues it is not able to communicate, that may also be a reason of suspicion. So in that case, this group management service may decide to not consider this particular replica managers any longer. So such kind of things can be done with group management service. Now there is something called view delivery. Suppose you have these group views which will be something like this thing, which will have definitely the processes. So whenever the membership changes, the group view will change, right? Earlier it was empty, then process P came. Later on what happened, suppose this was group G, this is group G1, you had P and now you have P1 also. This is comma, this is P1. Now you have suppose you had I was telling you about, you have G with P, you have G1 with P and P1, then you have G2 where any one of them, suppose P1 left, P1 is now no longer available. In that case you have again P. So these are the group views which can be shared with group managers, these managers, you know. In that case, whenever this membership changes, for this views may be delivered to each of the particular these what I should say, group managers or managers, members also. Okay. So now it will have certain requirements. Requirement means order, integrity, and non-triviality. Okay, so order means the way the process, if a process P delivers view, suppose this view, then the view, next view, suppose this is the order of views in a particular order. So if the process P is delivering these views, this G, then G1, and then G2, so no other process P1 can deliver it in a different order. All the processes will deliver it in the same order. This is order. Okay. Integrity means, so suppose P is delivering this particular this thing, group view, what it means that P is element of this particular group view. Okay. P1 is delivering, P1 can deliver only this group view, G kind of thing. Non-triviality means if a process Q joins a group and is something like P is equal to Q, okay, P is actually not the same as Q. So Q is always in the views that P will deliver. Let me explain it again. Non-triviality means, suppose there is a Q. Q is joining the particular group. Okay. Now, if suppose P and Q, and it is known that Q is always reachable from P, no problem. In that case, we can understand that Q is always in the view with the P. That is the thing about non-triviality. Now, let me tell you about the view synchronous group communication, where we are thinking about having extra guarantee on the correctness of delivery. So, three here things we are discussing about extra guarantee will be agreement, integrity, and validity. Agreement means a correct process deliver the same sequence of views. Whatever the views we have seen, V1, V2, V3, and so on, the same. If one process has sent like this, same will be done, right? Integrity, what we have seen, if a correct process P delivers a message M, then it will not deliver M again. Once it has sent a message, then it has been sent, no problem. Validity means if some message M has been transferred or transmitted, means sent, then okay, means one process which has been sent, it will be delivered, no problem. Okay, that is validity. So here in this scene, here in this figure, what you are seeing is you have three processes, P, Q, and R. It is showing the time lapse. one message is being sent from P to Q and R, and after that this P crashes. So these are the 4 scenarios we are discussing, where P sends the message, M reaches or not, we are unaware, means we are thinking about possibility, what are the possibilities. I don't know whether M reached this P or Q or R or not. Hello? In that case, but this P crashes, this information reaches, that means new view. Earlier view was PQR, now view is QR. Okay. Let us assume M, the message was received. Okay. So once the message was received, and after that view QR was received. What it means? The message was sent and then this view changed QR. So this message will not be delivered to QR. Right? This is allowed. However, another thing, like you got the information that P has crashed. So you have QR, and then you are getting the message from P. This is not allowed. Or maybe interleaved also. One of them, R is getting the message first, and then this information of QR, and any one of them is getting this information, the message later. This is also not allowed. What is allowed? The message should come before the information of the crash. That is the thing. Okay. So these are a few things in view synchronous system. The delivery of a new view draws a conceptual line across the system, and every message that is delivered at all the consistently delivered on one side or the other of that particular line. And this will help the programmers to see that yes, what has happened, whether we have to consider this M any longer or not, kind of these things. So we have already discussed these things. We have already discussed about fault tolerance and active or passive replication that can be done. So this was something about replication, and you have also discussed here about fault tolerance as well as the load balancing. As you have seen, there can be other methods of load balancing also, but you have seen that with replicas how it can be done. Replica is there, and the load can be shared with all of them. So these are certain things that we have seen today in this particular video. Thank you.